Hello there, Mr. Mechnick. I have a little podcast I'd like to share with all of you on, yep, you guessed it, water. So today we're going to talk about this little tiny molecule that we all know and love, H2O. And we're going to get into some of the unique characteristics that makes water such an important molecule on this planet, why it's essential for all of us, and some of the chemical and physical properties of it. So sit back and take a few notes and relax and hopefully learn something in the process. Did you know that 70% of your body is made up of water? Yeah, 70%. So roughly 75 to 85% of your brain is actually made up of water molecules. Most of your blood is made up of water, and 80% of your muscle tissues is made of water. So sometimes when we feel fatigued or tired, a lot of the times it might be due to dehydration, when your body doesn't have the water necessary to fill those cells up with all that H2O and deliver all the molecules that need to be transported from your digestive system into your circulatory system and get to those cells. So yes, 70% of your body is H2O. And 75% of the Earth's surface is covered in water. Not all of it's usable and fresh, because most of the Earth's water supply is found in our oceans. And of the usable water, 3% of the fresh water is found around the globe, and most of it's found in our polar ice caps. Whereas only 1% of that fresh water that we can actually use is found in lakes. Some of it's found in underground aquifers, and a large percentage of that amount is actually found in our Earth's atmosphere. So again, water plays such an important role for all of us. And to describe water, there are some unique physical properties that make water kind of a unique substance. First off, pure water does not have any color. It doesn't have any taste. It doesn't have any smell. One of the properties of water is that it freezes at a relatively moderate temperature at 0 degrees Celsius. It can vaporize at 100 degrees Celsius. As a result, we can find water at any given time on this planet as a solid, a liquid, or a gas. It's the only substance on this planet we can naturally find in all three states. That's pretty cool. The density of water is 1 gram per cubic centimeter, and when water freezes, it does this weird thing. It expands. So the density of ice becomes much less than 1 gram per cubic centimeter. The other important aspect of water is that it has a high specific heat value. This means that it takes a lot of energy to warm water up, and it takes a lot of energy to cool water down. And as a result, it does a really, really good job of moderating the Earth's climate. The other thing to mention today is some of the chemical properties of water. And we're going to spend some time learning about these chemical properties in the future. But one of the things that we should understand is that water is made up of 2 hydrogen atoms and 1 oxygen atom. So the chemical symbol for water is H2O. And the chemical bonds that hold these hydrogen and oxygen atoms together are called covalent bonds. So this is the sharing of electrons that happens between these 2 atoms. Hydrogen bonds exist when other water molecules are attracted towards other water molecules. And the reason that water likes to hang out with other water molecules is because we like to say that water is a polar substance. So water is polar. It's like a magnet. So the opposite sides tend to be attracted towards one another. We also know that when water sits for a while, it will naturally dissociate. It self-ionizes, meaning that it breaks apart into an OH ion and a H ion. And as a result, when you have an equal amount of OH and H's in a solution, you have a pH of 7. So that's what pH is actually measuring. It's measuring the power of the hydrogen ion that's in a solution. And the reason that happens is because water will self-ionize. We also know that water is a really, 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 really good solvent, meaning many things can dissolve in it. So that's why we typically don't find in nature pure water. Usually something has dissolved in it, and that's what affects water's flavor, water's taste, and can affect a lot of these other chemical properties when things dissolve in water. So as I mentioned, water is considered a polar substance, and what that means is this. You have two hydrogen atoms bonded to an oxygen atom. As a result of this, these hydrogen atoms only have one electron. They're going to share it with this oxygen atom. And when this happens, it creates a surplus of electrons on this side of the molecule. Because there's a surplus of more hydrogens over here on this side, because that hydrogen is sharing an electron with this hydrogen sharing its electron with this oxygen, so it puts more electrons over here on this side of the molecule, which makes it more negatively charged. There's less electrons over here, and as a result, we would say it has a slight positive charge. That's what makes water polar. And so, as a result, water has a slightly positive side and a slightly negative side. And because of this, water molecules really like to hang out with other water molecules. Polar molecules attract other polar molecules. So one water molecule will attract to the opposite side of another adjacent water molecule. And this often helps us understand some of the unique characteristics and properties of water. And because of this, the way the oxygen positions itself in respect to the two hydrogen atoms often give us this similar appearance to this little guy we all know called Mickey Mouse. So here you have the Mickey Mouse molecule, H2O. Because of the polarity of water and the fact that water molecules will stick together with these weak hydrogen bonds, we also have two other defining characteristics known as cohesion and adhesion. So what's the difference between the two? Well, cohesion simply means water likes to cohere to other water molecules. So cohesion is the attraction between molecules of the same substance. So water sticking towards other water molecules. So here's a really good example of this droplet of water and water sticking together with itself. We can also see that water likes to attract towards other substances. We know that water is also adhesive. So it can stick to other things like this tiny little piece of grass. And to really see some cool examples of cohesion and adhesion, watch this.
Is if you get a cloth dripping wet without gravity and you wring it out, what's going to happen? What will happen to a wrung out cloth? So, and I had to use equipment that was here on board the space station. We may have the coolest washcloths ever here on the space station. I'm going to show you. Here's one of our washcloths. And it's compacted. It's put down into this little tiny hockey puck so that it saves space. But when you open up a hockey puck and you pull out your washcloth, this is the one I'm going to use for the experiment today. And so when you open up your hockey puck and turn it into a washcloth, it was compressed in a great big vise somewhere. Okay, so here's my washcloth, like a magic trick. And now I'm going to get this soaking wet, and then we're going to see what will happen when we wring it out. Meredith and Kendra suggested that I dip this in a bag, but bags don't hold water in space, so instead I filled a water bag. This has drinking water in it. And I'm going to squirt a bunch of water into this washcloth.
Water's cohesive, it sticks together.
Okay, so here's a soaking wet washcloth. Get the microphone so you can hear me while I'm talking. And now let's start wringing it out. It's really wet.
Water's very adhesive as well, as it sticks to the washcloth.
It's becoming a tube of water. The water is all over my hands. In fact, it wrings out of the cloth into my hands. And if I let go of the cloth carefully, the water sort of has it stick to my hand. Okay, so the experiment worked beautifully. And the answer to the question is the water squeezes out of the cloth, and then because of the surface tension of the water, it actually runs along the surface of the cloth and then up into my hand, almost like you had Jello on your hands or gel on your hand, and it'll just stay there. Wonderful.
It's adhesive. Water is very adhesive.
Doesn't really unravel itself. It just stays there floating like a dog's chew toy, soaking wet. Great experiment, worked perfectly. Meredith and Kendra, congratulations. Great idea.
So surface tension, you were wondering? Well, here's what it is. It's the result of water being very cohesive. Water sticking to other water molecules can create this ability for water to create surface tension. So it's the force that exists between all of the water molecules, creating this barrier between the surface of the water itself and the outside. So it keeps objects that are more dense than water from sinking. If it's obviously too dense, it's going to break the surface tension and sink through that water column. But surface tension is one of those unique characteristics of water that makes it pretty special. So if we wanted to reduce surface tension and minimize that cohesiveness of water, one thing that can easily be done is add some soap to water. Soap molecules, what they do is they interfere with those hydrogen bonds that exist between water molecules. And so when soap is placed into water, it attracts to the hydrogen ends of the water molecules and basically gets in there and basically reduces that surface tension. It creates a much weaker hydrogen bond surface than when you actually don't have soap in the water. So what's nice about soap is that the soap will actually hold the dirt in suspension until it can be rinsed away. So the soap has the ability to attract water. It will also attract towards the dirt particles that might be in the dishes that you are cleaning. The last characteristic of water that I'd like to talk about is capillary action. So capillary action is basically the idea that water, because of its cohesive and adhesive properties, can travel through a small space against the force of gravity. So in a narrow tube, water will travel up the tube against the force of gravity because the water will adhere to the glass tube itself, and because water sticks together, it will cohere and travel up these narrow passages. So capillary action is kind of one of these unique things that allow blood to get to all of our extremities in our body. It also allows for water to travel great distances in plants. So before we finish up, the last few things I have for you to think about are some examples and which property of water is best described by the following images. So which property of water do you have here as this slow-mo picture shows a water drop hitting water? Which property of water do you think this one relates to? This bug being able to walk on the surface of water. Or water traveling up the stem of a plant, changing the flower petals to the color of the water in each of the cylinders. Or these tiny little droplets of water that beat up on the surface of a plant leaf. Or the water migrating up a piece of paper towel, or water traveling up the stems of a plant again. So thanks for watching. If you have any questions, please bring them to class tomorrow.